Hi there, I'm Graham Lewis, and in this short video we're going to discuss the sum to the first n terms of a geometric series. So in a previous video we discussed a geometric series which was 0.99 recurring, 0.9 plus 0.09 plus 0.009 and so on. So this is a geometric series. So the first term is a, which is 0.9 in this case. The second term is multiplied by a common ratio, so it's AR, and the common ratio, the multiplying factor, is 0.1. So AR is 0.9 times the 0.1, giving me the second term of 0.09. The third term is similar. It's AR times R, or AR squared. AR times R, which is of course AR squared, because you're taking this term here, the second term, and you're multiplying it by another R. So you've got 0.9, your first term, times 0.1, that gives the second term, times another 0.1, giving you the third term, 0.009. So we can see that in general, the nth term of this sequence would be AR to the n minus 1, because the first term was just A, and you can think of that as r to the power 0. The second term was AR to the 1. The third term was AR squared. So the fourth term would be AR cubed. The 10th term would be AR to the power 9. So the nth term would be AR to the n minus 1. So now we're going to look in general at the sum of the first n terms. So if I write down my geometric series, the sum of the first n terms, the first term is A, the second term is AR, the third term is AR squared, the fourth term is AR cubed, plus ... plus, and then I'm going to write the last two terms down. So the last term, the penultimate term would be AR to the n minus 2, and the last term would be AR to the n minus 1. So now what I'm going to do, I want to prove and get a formula for this. So what I'm going to do is multiply all of that by R and get another equation. So I'm just going to multiply everything by R. So A times R, AR times R would be AR squared, AR squared times R would be AR cubed. So I'm just multiplying every term by R, plus lots of terms in the middle there, and AR to the n minus 2 times R is AR to the n minus 1, and AR to the n minus 1 times R would be A times R to the power n. Okay, so now what I'm going to do is consider this to be equation 1. I'll just make this a little bit smaller here. So I'll consider this to be equation 1 and this to be equation 2. And I'm going to subtract them, because when I subtract them, lots of things will cancel. Can you see that? It'll be really nice. So I'm going to do Sn minus R times Sn. So obviously I've got A plus, then I've got an AR minus AR. Well, AR minus AR is not very much at all. Cancels. And then I've got AR squared minus AR squared. Cancels. AR cubed minus AR cubed. Cancels. And then if I had an AR4 there, it'd be AR4 minus AR4 cancel. All the middle terms will cancel. They'll all go with each other. And finally, I'll have an AR to the n minus 2. That will cancel with the one before there. The AR n minus 1, the last term here, will cancel with the penultimate term there, second to last. And I'll only be left with this AR to the n. And of course it would be minus AR to the n, because I was doing minus the equation 2. So I have minus AR to the power n. Well, that's looking nice. Lots of things cancelled. Let's factor the left-hand side. Let's take Sn out as a factor. I've got 1Sn minus Rsn. Let's factor the right-hand side. Take A out. I've got 1 minus R to the n. And then I just need to divide both sides by 1 minus R. We're assuming R does not equal 1, of course. So I have a formula now, divided by 1 minus R, assuming R does not equal 1, because obviously I can't divide by 0, and we've proved a nice formula for the sum of the first n terms of a geometric series.